And make sure you're recording. Okay. Hey, Taylor. Can you hear me?
Hello?
Okay. Can you hear me? Because I was having troubles earlier.
Oh yeah, I hear you.
Okay, good. And you can see my shared screen?
Yeah, I although yeah, I mean I see the text, yeah.
Okay. It's a little cut off, but you can see it, right?
Yeah, yeah. I was just making sure it's not like a program that's not supposed to show.
Yeah, I was like, I had to flip to a different one instead of like a screen. I did like the extent because like it wasn't showing this border for some reason.
What software is that?
This one, this is I'm just using Zoom. Or what are
Oh
you
no
talking
no
about?
like you know it says Cox 18 Coding Lab 3, like what is that software like
Oh,
using?
the one I'm using right now?
Yeah.
It's Bluebeam.
Bluebeam. Oh,
Yeah, it's
I
kind of like
feel like I heard
creative.
that before. Yeah.
Yeah, it's a nice one. It's kind of like which one is that one? It's like there's a lot of markups that you could do for
Mm,
it.
okay. Is it free?
It's not free.
I
It's
see.
a yeah. There's a free one for like I think Microsoft. There's a it's better than Adobe. I forgot what it's called,
Hmm,
but like you could use it for like teaching whatever.
I see.
Yeah. Oh yeah, were you able to get that pseudocode? It looks really good. Like it's
Oh
on the
yeah.
code. It's encoding the first part of Coding Lab 3.
Yeah. Yeah, because I didn't take a look at coding lab 3 when I spread the email, so I was kind of confused, like, well, what do you mean pseudocode? And then I saw the assignment, I was like, oh, okay, I see what it is.
Yeah. Yeah, I think what it is, I didn't really have that before.
Mhm.
I think it'll be good if someone shows up today, but like, I think it'll be good to show them like how to create like a pseudocode.
Yeah, yeah. Adam's kind of explain like what it is and like how to do it, or how to like make one, and then how to transform
Oh yeah,
pseudocode
I
into
can make
code.
you. Let me make you host
Yeah.
actually, because so you
Uh,
can do
oh
the
yeah, yeah.
background.
Sure. Yeah. Okay.
Okay, there you go. Someone showed up.
All right. Nice.
Hey guys, we're gonna begin in a bit, maybe 5 minutes. But here's the demo. Yeah, Jerry, I'll give you that after lab. Okay, I think it doesn't look like there's gonna be much more, so let's just start. Hey guys, this is COGS 18, Coding Lab 3, week 3. You guys are almost done. You guys just finished your exam 1. We'll get that graded for you guys as soon as we can. But for this week, you already know us, Paul and Taylor, and we're gonna be starting with FAQs from Piazza. And then just some logistics. Today's coding lab is going to be due to before midnight, and then your assignment 3 is due next week Monday before midnight. And then for the demo today, we'll be talking about a lot of things, but I'll try to abbreviate some of these. But encodings and decodings are ciphers, functions, errors or debugging, and then I'll kind of show this type of function, specifically datetime. I think there's going to be some assignment questions on it. All right, so Taylor, you want to start?
Yeah, sure. Let me share my screen. Okay. Can everyone see my screen?
I can see it, yeah.
Okay. All right, so I'll start with pseudocode. So I think the professor gives a pretty good example of what a pseudocode is on the Coding Lab 3, but I guess I'll just kind of talk over it briefly. So pseudocode is basically like a skeleton like coding of the function you want to create, or any other, it could be class or function too. But basically you write in English and don't really code in Python. And then I did the example of sorting an array from some of the largest integers. So this is my pseudocode. I kind of comment like what I'm doing for each line. And so first I have to create a random numbers, and to do that I have to import some libraries. And then I define the function, create a new list, get the new numbers, and then call the sort method, and then return the sorted list. I believe in Coding Lab 3, you don't have to actually, code the skeleton or the pseudocode in Python, but I just say it anyways to just to guys show you how it is done. So I just copy and pasted this whole cell, and then basically put Python codes. So I basically imported the libraries, create a new list. It's like empty list, and then get the new numbers, and then call the sort function. The sort method. Sort method basically sorts the anything in the list in smallest to largest or alphabetical order if you specify that in the method. Oh, and then one thing for the functions, you can define a variable to have a default value. So this array underscore sort function has a default value of I equals 100. But here you see that I said I equals 10. So I got 10 numbers, but let's see, if I were to not specify that and do nothing about it, let me just run this. You can expect to have a lot more numbers because I equals 100. So that's pseudocode. So basically, you kind of write in English and then, transform that into Python codes later. And let's go to functions. Okay. So I did so I put some examples from the coding lab. This is my own example. So my function is called my underscore cool underscore function, and then it takes input. It could be a string, integer, float, any type of variable. And what my function does is it checks if the input is a Boolean type, so true or false. And if it is a Boolean, it prints the input is a Boolean. And for anything else, such as float, integer, or something else, it will print, I don't know what that is, or what this is. So as you can see, I pass in true, and then since it's a Boolean, it prints the input as a Boolean. But if I put a number, like 365, it says, I don't know what this is. And I guess I feel like the hardest part of the coding lab is the palindrome function. So I defined a function called reverse string that takes in a variable string. And I purposely removed this code just to not give you the answers, I guess, to how to reverse a string, but it should be pretty easy. And so if I type in the string hello, it's going to return the hello string in reverse. So OLLEH. And then to actually use the palindrome function or define it, this is my example. So this function itself takes in an input called input underscore string. And again, this could be a string, integer, or any type of variable or input. But I'm defining here that string underscore 1 equals whatever we put in to the function. And notice that I'm calling the reverse string function from the top, and then inputting this input from this check underscore palindrome function. So what this is going to do is that string 1 is going to store the input string, and then string 2 is going to assign whatever you put in here, but reverse it, because it's calling the reverse underscore string function. So, and now the conditionals. So if string 1 is equal to string 2, then return that it's a palindrome. And if it's not, don't, or state that, bummer, not a palindrome. So you can check here. So this apple string is my input string in this function. And obviously apple is not a palindrome, because if you reverse it, it's not apple again. But if you do madam, that's a palindrome. And then says, hey, that's a palindrome. So this coding lab is pretty short because I don't think we had much lecture on it to cover it. So yeah, so this is all I have for week 3, tips and tricks. I guess the main thing was calling the previously defined function into the later function. But let's say you had this function not defined here, but let's say this. Say defined here. This will not work because at the moment, check palindrome doesn't know what reverse underscore string function is. So make sure to define this before you define or use this function. Okay, so I'll pass it over to Paul now, but if you have individual questions, you can message me and I can take you to a breakout room.
Cool, thank you, Taylor.
No worries.
Let me share my screen. Just gonna go over the coding lab that you guys have today. So it's really short, yeah. It's gonna be about algorithms and functions. And then Taylor talked about this, the pseudocode is the first part. And then the next part is computational algorithms. This is just like, the basics of like why you're writing a code is to create these like functions and classes. And then it's like the whole basis of programming is creating these. And then the last part is about functions. So this is where it's gonna get fun, because then you're gonna get the first hierarchy of like programming. There's functions, classes, and then modules later on, and packages. But this is probably one of the critical points. So I wanted to go over this mostly. So for this coding lab demo, I'm going to talk about, I didn't really cover this in the previous, so I wanted to go over it just to get more of a repeat, maybe hopefully for your final. But the first part is going to be about ciphers and how to create them with built-ins and then customs. And then we'll talk about functions and then errors and debugging. And then the last part is going to be date time. If I don't get to it, you guys can just check I sent you guys the link. But okay, so what are encodings and decoding? So the way that you look at ciphers, like that, Cipher is just this system of having encrypted code, like phrase, and then you're gonna encode it so that you can encrypt it, and then from the encrypted message you decode it. So you guys already learned this, but just a review. And as you guys remember, we talked about a lot about loops and collections in the previous lab. Well, the basis of like creating a cipher is using these loops for each of the encoding and decoding. And then it's just looping through the characters in a sense, of like a collection of strings. And then these examples are just somewhat of a repeat, but then of what you guys already saw. But then this first one is creating a built-in cipher. So what I mean about built-in is it's just going to create, like you can always define the encryption, and that's like you can use a custom like for each letter, and the way you do that is like from a dictionary. Like so, like for each like symbol within like a message, you want to switch it with another symbol. But for the built-in, this is just showing like the order of it. So what you have here is like the original message. So some corny messages. The chain is only as strong as its weakest link. And then the order of it is you apply the encoding. So you encode this message, and you're going to get this encrypted text, which is this, but it's an encryption. And then the next thing is after you get this encoding is you're going to use this and then decode it. And then your output is going to be the output back your original. So that's technically the system of it. And then this is just printing the text. And then now let's start with like the very first thing is like creating an encoding. And then what this is just first thing you want to do is like you always want to define your variables. So this first part, like you want to define the number of characters you have there. I mean, the less you have, you're going to see that like in your encoding encryption, there's not going to be a varied amount of like characters. So I always try to increase that amount. And then so this isn't saying original message. And then how you want to create this encoder is just what we talked about before. It's kind of like your counter or like your empty sequence. So your empty sequence is this character, empty character variable, which is going to be this. And what you're going to do is from your sequence here, you want to for loop. You want to take a character counter and then loop through all the different characters in here. And what this does is it's going to populate your encoded message from all the character and key variable. So one thing to remember when you're doing these like encoding and decoding is the difference between those two, because like this part is very similar. This is the structure of it, but the key differences is just your sequence lists, or what I mean by that is like what you're trying to loop into, like your collection of lists, is your original message for an encoder. But then within your loop body, what you're trying to modify is your encoded message. So this is what you're trying to like build from your original message. And then another difference is the key. So this part right here, so this is adding the key to your character. For each one of these, you're adding a key character. So those are the three main difference for encoder. And then with that, you're just gonna output what you have. So this is like the first part, from the original to the encoded. And then the next thing is to create this decoder. So a decoder is just, now you have this encrypted message, right? And then you want to output back the original message. So very similar structure. You start out with this, key variable, but this time your sequence is going to be your encoded message, not your original. So that's what you're going to loop into. That's what the first difference. And then the second difference again is within your body, you want to populate this decoded message. And then the last difference is for a decoder, you're minusing the key variable, but then for the encoder, you're adding this key variable. So like the way you create it is just a for loop, but then knowing the differences is just trying to put that in a perspective and now you just have to print, just to look at like the second part is you have the encoded message and then the decoded. So with that, we're back to combining them. And then since now you know how to create it, so you have this, which is like encoder, and then the decoder, and then putting it all together, the original, which what you began with, and then encoding and decoding. So I guess the last part here is just creating your custom cipher. This can get more complicated, but one of the ways you could do that is just, having a custom encoding and a custom decoding. So this is the way it's simplistically how I would see this is you're just switching like an equivalency of like your symbols or your strings or whatever number, but then knowing what your key is and then what your value is. So this key, which is on the left of the colon for a dictionary, is gonna get switched with the value. So the decoding is gonna be the other way around because you're trying, because whatever your key is gonna be coming from the encoder, and for the encoding that the key is from the original message. So just knowing that logic. So here we have another custom message. It's gonna be anything. And then how you would simulate this custom encoder and decoder is kind of similar to what you did before. But then now, instead of just like a for loop, we've learned this. It's going to be a combination of for loop and conditional. So what happens here is, for an encoder, you always start with your custom message, your original message, or your sequence, and then you're going to populate your encoded custom. So very similarly, the only difference here is this part. So what's happening is you're not adding this the built-in character, this ordinary character. What you're adding in is the custom dictionary that you created. So this dictionary, you're trying to index each one of these and then switching out what you have for the symbols. So very similar to for both. Just remember, you can always look back to this, just the syntax. And again, in the end, you're gonna get this. Okay, so enough about that. Let's talk about the main bulk. So functions, conditionals, and loop combinations. So what you're trying to create with a function is technically kind of like a cover, or like it's what you can group all these different like commands and for loops and then while loops and all the conditionals that you've learned so far. You can always put this inside a function, and the reason why for that is so that you can lessen the amount of like code that you see, because then the function can just take in arguments, or what you call inputs, and then those inputs are local to your function. And as a user, what you want is what you're returning from that function, which are your outputs. So very first thing to learn is how do you get like how do you learn what your function does, or is you can always implement like doc strings, and I'll talk about this more in like the examples. And a doc string is just a documentation of what your function does. Like it tells you in its basic form, you can have the inputs and the outputs and then describe what their function does. And then another way that you can, so the way that you can access a doc string is using that function you created, the function name, just put in like a question mark at the end. And then, or you could do like a help, and then inside the parentheses is your function name. And then another way would be, like when you run your function like this. So I'll show this clearly in like the examples. And then when you're talking about the arguments, there's going to be two types of arguments for functions. There's going to be positional arguments and then keyword arguments. And positional arguments, what ends up happening with this is like the order of your like the inputs inside the parentheses matter. But then for the keyword, they don't follow the same order. So it's a little abstract, but it's going to become clear once I show it. And then these methods, we talked about these before. We covered functions of methods already. And a method is just a type of function that comes after like an object. So this is kind of like the syntax. You have like this variable and you put in dot, and whatever this method is, you've seen this like, if you have like a string variable and then dot capitalized or dot lowered, that's a method. And one way that you can access the types of methods is you have that variable and you put in this dot, and then you press tab, and then you should have like a prompt box that you can scroll into where you can find all the available methods you have. So let's start out with the first example. So here's what I was talking about, doc strings. So the way, before that, like the way you define a function in its basic form is you have this keyword def, and then you put your function name, and then inside the parentheses are all your arguments or inputs. And make sure you put this colon or it won't work. And then the doc string is what you put between these like triple quotation marks or apostrophes. And then typically this is what I do. I put like, it's easier. It's always good to know like what you're putting in and then what you're outputting. So this input is what it's in here. And then this output is what's being returned. And this is usually, what your function will output like after you run it. So, and this is just arbitrary. So everything you've learned, like, encoding, all the functions that you commands, goes inside the body of your function. So that's and then you just name it, and it'll perform the same way, but then it's just much cleaner. So just remember the syntax. You have the name here, the doc string, the body of your function, and then this is the output, the end of your function. Okay, so now I want to show you guys how to access a doc string. So, like I said, one of those ways, let me just run this first. One of the ways that you can access a doc string is doing like the function name and then a question mark. So that when you do that, this happens, and at the bottom you're gonna see, okay, this is the name of it. Everything that you pretty much put here, and the reason for that is typically these functions are gonna be not visible to you and accessible. Like right now, you see it because it's I wrote it, but then sometimes it can be hidden, and then that's the reason why you want to access it using this question mark, because then you'll know what it does, and then all these other stuff. And then the other way you can access that is using a help. Using a help function, same exact thing. You could use either one. And then this next example, well, it's just an example of like how to use how to create a function. So this one I'll run through what it does and then what it outputs. So this is the name of the function, greet. And then what this is doing is it takes in two different types of arguments. And then what you see here, like when I do this, this is just gonna give it like a default. Like when I define like an argument, and then I put equal sign. So what ends up happening is it's just gonna output this, hello, and then the name is just a concatenation, right? And then plus message. And I didn't define a message. So whatever, this is the default function or default assignment of this input variable. So if I don't define a message, it's just gonna, and what I mean by that is like over here. So how you read this is when you run greet, which is here, it's gonna print this hello, right? And then the name. So you put in Kate, which is the first argument. So that's gonna be here. But then I didn't define this message. So if I don't define it, the default is just gonna be what I put in the argument. But then you could also define that argument, like that message argument. So that's what I did here. And once you define a second argument for message, it's gonna overwrite that default function, default assignment. So hope that makes sense. And then the next one here is I'm talking about the types of arguments. So you have positional and keywords. So we'll talk about positional first. So what this means is like your order matters. Positional means your order matters. So when you look at this, so I defined these two types of arguments, and as you can see, when I switch them, the output is going to be different. So 2, 1 will output 1, and if I do like 1, 2, it's going to be -1. So that's what I mean. Like the order of these arguments or positional arguments matters depending on what output you get. So it's not going to be the same output. But with keyword arguments, The order doesn't matter, which means like whether you switch these, you're gonna get the same output. So here, how you do that is actually assigning a value. You know, you're gonna assign a value the same as like how you wanted it to be default to the actual input variable. That way, when you switch them, it doesn't really matter because then it's being assigned. So that's technically the syntax of it. If you don't put in like an assignment here, like equals something, that's a positional. So depending on the position, you're gonna get a different result. But if you define this, it's got a keyword argument, the result's gonna be the same either way, even if you switch these. And then now let's talk about methods. So a method for strings would be like .find. And this is just an example. So I have a string variable here. And then, you know, what I have here is like, I want to find the position. So this .find is it finds the position of t in your string variable. I'm not going to count it, but this is just what it does. This is an example of a method called .find. And then here is like using the method shortcut. Let me just show you what this means. So like I said, if you press tab, you're gonna see this. So these are types of like methods you can use. I just put capitalize like that. And then, so if you don't know what it is, I'm getting an error. That's weird. Oh, that's probably not. There you go. So don't forget the parentheses. So the empty argument is, yeah, that's with all the methods. And then you can also use a method with like dictionaries and loops. There's a lot of these. It's a matter of like experimentation, just knowing what it does. So you do this. This one just tells you all the different values. So then you know what a dictionary is. So when you do dot keys, you could also do dot keys. And then what it does is it just outputs all the different keys. And then for this next one is this is an example of creating a function called factorial. I think a lot of people know what this is. And then this is just me adding like a doc string and defining the body of the function. So I'm not going to really explain what this is, but after you create this factorial function, then this is how you would use it. So the input though, is always good to remember it, right? So it takes in this this integer input or number, and then the output here is whatever you printed, or you can have it not output anything. But I wanted it to output like print and whatever you know how to do this. It's seamless. The only thing you see is the factorial name, and then everything here is just inside or local to the function. And then you could also define like a very complicated function. I mean, what we have here was just a for loop, but then you could also do like a bunch of conditional statements. And remember, like once you put this return, this is what, and for each one of these, you can either print, if you have, or you can return a number. So I'll show you what this does. So after defining the function, you can use it by just with the function name and then the inputs that you need. So this one is very similar, but then it takes in one integer as an input, and then the output can either be like just a bunch of strings or an integer. So let's do something like besides just putting in one, just to show you guys what this does. And if you guys know what this function really does, like Fibonacci, just add, like what I have here, it just adds what, a sequence like 0 + 1 + 1 + 2. So that's what you have. And then for the next one, this is a more creative type of function. And it's called like body mass index. This has like more than one argument. It has like 3. And then I define that clearly here. And then, I have like a calculation here, and then a bunch of conditionals again. But with this, I mean, it's the same thing. You define it, and then you can use, like, you can define your, like, what I'm using here is like, first of all, I want to run this like maybe 3 times. And so the nice thing about a function is you can find that pattern. If you want to use like a function within a loop, and then you need to find like a pattern, like, okay, like for example, like an equation, like a mathematical equation, the variables, the input variables, that's what you put here. And then if you want to test your function, you could always define those different variables separately, like different variables here that you can name apart from this. These are just dummy variables. So anything you put here can be a different name, like if you have multiple ones. But then it's always good to track, make sure you have a descriptive variable naming. So that's why I did 3 different types of each one of these. And then I just, outputted the body mass index, and those 3 different types of variables, I put them as my inputs. And this is what you get. So it's pretty nifty. Here's another example. You guys will learn this later on, but I just wanted to like relate everything together. Is when you're importing like a module, you could always use like a function, and then a function of a module, which is kind of just like an exported function. I'll define that more clearly later on. But so once you define this, this random function is right here. So there's a bunch of things here, but what I want you guys to know is just how to define a function, and then what goes inside, and then, what's the proper syntax. So here's getting kind of complicated, but just what I'm trying to do here is just trying to use this coin toss function. So after you define a function, you could always use it in for loops and whatever fashion, the same way as you would use like a regular command. All right, so that's enough about functions. Let's talk about errors. So there's a lot of these in your assignment. So errors and debugging. I mean, you would think we would learn this in the beginning, but it's always good to encounter them first. And then, you probably, I mean, for a beginner, I kind of encountered pretty much more than half of these. And I just didn't know how to actually debug it. So when I say debugging, that's how you fix the error. So, and how you can really know what these errors are, I mean, you could always just like figure it out. But what I do is you can actually access the documentation, the Python documentation. So I've included this in here. You guys can go on it. It'll define these, and then how, like, why it's happening and how to resolve it. But instead of like defining it, let me just show you what they are. So for a debugging syntax error, or if you want to like fix a syntax error, this problem, first of all, is can be encountered in many ways. You could either have a missing colon or a parenthesis. So anything that a structure error where like what you've had before was like maybe you forgot like a colon, such as here. So you're gonna get a syntax error, but then how you fix that is you just add the colon in there, and you're good to go. And then another one is maybe if you're missing like a parentheses. Let's see this one. So that and then when you want to fix it, just add in the parentheses. And another one is an indentation error. You've seen this a lot, and this is why we're trying to remind you to always know how to or align your commands. So how you would do this is you just either space or tab until you get something, and then there you go, there's no error. And then the next error is a zero division error. This is very self-explanatory. Just don't divide by 0. And then the next one is a name error. How you encounter this is it's either you're missing a definition or assignment of variables. So for example, this one, and what's good about like looking at these error outputs is it actually tells you how to what line you're getting the error from, and how you interpret it is like from here, and how you would go about in doing that, because sometimes these number lines don't show up, is you go to view and toggle line numbers. So view toggle line numbers. So it tells you it points at 7, so you go here, so oh, what's happening? So the reason why is you didn't define 5. So that's why you're getting a name error, because you didn't define that variable. So once you define it, you're good to go. And then another one is index error. How you encounter this is missing index to which reference of like when you're slicing something is associated with. And how you would solve it is, so for example, this one, right? This is where the error is, line number 6. Is it just know, like, obviously you don't have a 6th number here. So make sure you know, like, let me see. There you go. Make sure you know like what you're indexing. So that's why it's always good to know the length of it. So if you go over bounds, you're gonna get that index error. And another one is a key error. So this key error is indexing a key that does not exist in a dictionary. So here's an example of it. So there's a dictionary, right? And I want to print like, okay, I want to know the value of this dictionary of the key ln, but then ln is not here. So that's how you're gonna get a key error, because you don't have an ln key. How you would resolve that is either using this get method, and what ends up happening is this is just kind of like when you're adding something, you're adding a key and a value into this. So you're gonna get, now you have an ln, so the value is this. And then another way is doing this is .get, but then you didn't assign like a value, so you're just gonna output none. So you don't have to assign a value, but then as long as you have a key, because this is a key error, And then the next type of error is a value error. How you're gonna encounter this is creating an integer out of string and referencing in a variable from an empty list. So that's just saying that if you know how to query like a type of a variable, or if a variable is is an integer. So obviously, logically, when you do this, you're not gonna get anything, because cat isn't an integer; it's a string. So that's how you encounter it, a value error. But then if you do this, so it's really, that's why you need to know the types of variables and the inputs that you can put in commands, because then you're gonna encounter a value error. If it doesn't, it's apples and oranges. You need to know what they are. And then another one is a type error. And what this does is, if you're trying to add like a number to a string, you can't do that. You're gonna get this type of error. You need to know if something is an integer. So that's the only way you can add them. Or if both of them are a string, you could always concatenate them. But they just have to not mix and match. Another one way you can fix that is like, you do have this string, right? So the string, you make it into an integer, and that should be good. Or you can make the number into a string, so you can concatenate these. So always remember, it's fixing a type error or like a value error is knowing your data type and what you can do with it. And so with all of that, that's how you debug it, like within its certain like type of error. But then sometimes, when you want to do a catch-all solution, or you guys gonna see this, like it's through a combination of try and except. So for example, when you're trying to code like something and you don't know that you're gonna encounter, for the most part, you're not gonna anticipate that error. But if you know that that you will, you could always do like try and except. So what you do here is like, what you put in try is something that will have like, you'll like anticipate that, oh, maybe you're gonna get that type of error. For example, this one is a division, right, by 0. It's a modulo 0. So that's what you put in try. And then except is, okay, so now that you're gonna encounter like this type of error, you put it in here, the error type. And then what you do is, once you get this error, I want you to do this instead. So what this does is it allows you to continue with your code, because every time you get an error, your code's gonna stop. But if you do a try and except, it'll continue, but then you're gonna output something. So it gives you a warning rather than an error, per se. So that's what a try and except, it gives you a warning rather than an error. So right now you probably don't know why you would use this, but over time you're gonna build like knowing that these types of errors, because you really need to know when you're gonna encounter these errors in order to build a try and accept, because that's what you put in try. And when you know that there's certain ways that you may not be able to fix an error, you could just output a warning. And then you also want to continue. So this is also the reason why you want to do a try and accept. So you can do this with all of them. And then I'm not going to explain each one, but the output is just this. So yes, you have this type of error, and then here's the warning. So it's nifty. The nicest thing is you can always make your code to run, and it doesn't stop. So that's the main reason why you do this try and accept. And then, of course, the next thing would be to go into the statement and try to fix or find or what it does here to check. Okay, I think we're almost done, but the last thing here is just covering a datetime method. So this type of method is just something you're probably going to see in your assignment. Why I'm putting this in here is just to serve more of like a specific type of method and then how to use it. So this datetime method provides ways to query a calendar component. So like numbers of years, months, and days. And there's three examples that I will use the method for datetime. So this first one. So how you would access these datetime methods is first you have to write this. So this is very important. Like you have to remember to import this module. You'll learn more about modules later on, but for right now, just look into this and then just type in from datetime and then import these functions. So that, I'm not gonna explain what these are, but that's how you do it. The reason why you want to do that is it's not built in the Jupyter Notebook that we have, this datetime, and we want to get these functions from this module. So a module is kind of like an external function, not built in. So after you do that, the reason why you're doing that is so that now you could use them. You can use the methods for datetime. So for this first one, I mean, what it does is it just gives me the day. So this date, for example, and this is just assigning a variable. So this date function has these arguments, and then in here you're gonna have like the year that goes from 1 to 9,999, and then you have the month that goes from 1 to 12, makes sense, and you have the day that goes from 1 to 31. So those are the inputs, and the output of date, the date function, is it gives you the day, the day of the week. So Monday being 1, and then Sunday being 7, 2/7. So wait, let's see. What if we input today's date? So 7, 15, and let's see if it works. So it says 3, so that's Wednesday, so that works. And then if you do, let me see. So it does this first. So if you don't run this next one, so nothing's gonna output. But then how you access that date, that number, is that variable, and then .iso weekday. So the ISO weekday gives you this number, and this number is associated with the day of the week. So it's Wednesday. And then this next example shows you, okay, latest and earliest dates. So like the earliest and then the latest date that you can get with datetime. And that's how I was able to get these. So if you go to like maximum date, this is the year, this is the month, and this is the day. So that's how I was able to get these. If you wanted to get like the minimum, it's 1 for the year, all 1. And then for example, what if you don't know like the type of functions you could use with datetime? You could always do this, dir like directory and then datetime. So all of this can be used like, .max, .min, it's all in here. So that it's just another way of like, instead of doing that, you could always do like the dat tab. If you did like tab, it's the same thing. So this directory is the same thing as dot and then tab. And then this last example here is just a pretty much it uses all what you've learned from datetime, and then you can define a while loop, put in a try and except, and then you can even put in conditional. So just putting all the different skill that you've learned thus far, and then creating a function out of like an external function and all that. And then you can always interpret what this is doing, but what it is really is you can get the number of days, which is your output, from the inputs of year and month. So for example, the number of days in the 2020 April, and that are Sundays. So this is what it's doing. So the year variable is 2020. The month variable is April. So 4. The day variable Sunday, remember that's 1. Or actually, hold on, Sunday is 7. So when you do that, and you run this whole thing, it says day counted compared to the number of days, Sundays, within April 2020 is 3. So yeah, this is just when you're doing like functions. I mean, you've already known this, but that it's most important to know what each line is doing. So you always, I mean, if you haven't started already, try to like document each line. We've shown you guys how to do these with hashtags, but like if you're doing it on your own, you know what you're doing. But it's really important from now on to really like take a step back. Not just do something and then make it work, but take a step back and like break down in words what your function is doing with each line. The reason why is 2 things. I mean, for you, it helps in like the logic of what your code is doing. And then I guess secondly, if you're giving someone your code, in the future, and then you want them to, I mean, it's not just you creating a code, like, it's like a collaboration. And then if they see step by step what you're doing, it's just more streamlined, and you can always pass it to someone and they can pass it back to you. But yeah, that's pretty much everything. If you guys have other questions, let me know, or let Taylor know. And you can always email me. And thank you so much.
Hi, Taylor. Hello.
Hey Terry, are you staying on the second hour? Yeah. All right, Jerry. Do you want to just show me real quick? Part 4. Okay. Okay. So what's your question? Okay. Cool. Cool. Yeah, that's the one that he covered in the beginning.
So Paul, are you here? I still have a problem about the part 4 question.
Okay.
So I sent you my code, and I try to write the conditional as when counter is bigger than 0, and
Yeah.
Taylor told me that this will make it an infinite loop. So what can I do with it?
Okay. Just send me, I guess, what you have, and then I'll look into it later. But
Okay.
what you have right now, I mean, let me see. Yeah, I would have to look into it. I need to know what it outputs. But it's only this, right? Part 4, just
Yeah.
this part. Okay. Yeah, no worries. I'll take care of it later. I'll give you a message or like an email.
Okay. Thank you.
Cool, all right, Jerry. Mhm. Hey Natalie, let me say something. So like, what do you mean by example listing names? And I know I could use sorted names. Yeah, like a pseudocode is just, it doesn't have to like output anything. It's just a way to write something in like a logical order of your code. Does that, yeah, does that make sense?
So for the like pseudo function, putting an example, you just put like what sort it actually does.
Yeah, I mean, you could explain it, but
Okay.
like,
For part two, the coding model.
let me see. Part two?
Yeah, so it says to take one of those examples and to kind of put it into pseudocode.
Yeah, kind of like this. Here, hold up. Let me look at what it's supposed to be. Yeah, like if you look at that given example, I mean, you can take like any of these, and then what you would do is like you could put in the syntax of like a definition, like, and you can just name it your own. That first line is going to be kind of simple, but then and then the return, you could return nothing. That's how I would do it. and then like inside the body of your code, you can just put in like a bunch of like hashtags, like to comment what you would do, and then pass, like put in pass every time. Does that make sense?
Yeah, kind of. I'm confused what pass is. Like it just moves to the next thing.
Yeah, pretty much. So it doesn't do anything. It'll like, I mean, you could, as long as you define it, there's no error, because then you have the beginning of your function, the def, and then the end of your function, which is return, and then just put in none.
And
Or you
then just
can,
hashtag with the steps.
yeah, and then the main thing for a pseudocode is just laying out in layman's terms or whatever words you have in like a comment, like a hashtag and a text. There's like
Okay.
no right or wrong. It's pretty much just what I would do. Like maybe like a systematic way of thinking about it is like you could put in like, okay, if you take one of these guys, right, and then maybe you know how to. I think the best way for me, I don't really like doing pseudocode. Like the best way for me is kind of like reversing it, like knowing how to code something and then coming back and say, okay, what did I do? So that's a pseudocode, like what you did. Like you could say, find this, and then the next thing would be find this, and then you could even say like, if there's like a mathematical thing, say this divided by this. And like I guess you could also put in like, what do you want to get out of your like function, like return your output. You could put that like as like a comment. I mean, like for this one, it doesn't really matter what you put, as long as you chose like an example, and then you have like the right syntax. Right? So make sure you have pass, and then def, and then return. As long as you have those, like we'll try to read what you have inside, but it's not a big thing.
Great, thank you.
Cool.